Okie dokie. In this video, we're knocking out a practice exam for 1026. I think for exam 2, if I'm not mistaken. Let's jump into it. Question 1. They say, using the above slope field, complete the following statements. Y equals 3 is, well, what can we tell about y equals 3? There's slope lines of 0, the slopes of 0 through there, and these lines are approaching it from above and from below. So what we have is an equilibrium solution that is stable. So because the slope, the y prime value is 0, that means y equals 3 is an equilibrium solution, and because these lines are approaching it from above and from below, that makes it a stable equilibrium solution. Part B, given the initial condition y of 0 equals 4, y of 8 is. So y of 0 equals 4 means we have a solid dot, a point at 0, 4. And then if we just follow the arrows from there, we get bam, bam, bam. So basically, we connect the arrows from there and write out that function. So basically, like, this line is the solution starting at 0, 4. So basically, the y value at t equals 8 would also still be 4. So it's just going to be 4. Now, if it had started at like y of 0 equals, 2, then you would have started right here, and you would have followed these arrows, and then you would have written out this equilibrium solution. So the answer would have been something like y of 8 is, or I guess in this case, sorry, y, or no, that would have been right, yeah, y of 8 is less than 3. It wouldn't have equaled 3 exactly, but it would have, written out that asymptote and been just strictly less than 3. To be honest, it probably would have been between 1 and 3 because 1 is the other equilibrium solution, and they would have just considered it as in between those. I hope that makes sense. That was just another example. Number 2, complete the following statements, make them true. Okay, so I'm going to say the integral of 3t squared is 3. You could say 3t cubed over 3, or you could just say t cubed and then make sure to add c. I'm just taking guesses here on the drop-down boxes, but the integral from a to b of f of x represents, you could say, the area under the curve, the general family of antiderivatives of f of x. Actually, no, sorry, that wouldn't be a general family. That'd be, a definite integral from a to b. So it'd be like a specific area under a curve of f from a to b. It could be just the exact antiderivative. I don't know. That's all I got. You'll figure it out. F of x is an antiderivative for this. Then, all right, this is helpful. The integral of f of x dx equals capital F of x, I guess. Or they're looking for the derivative way. So if f is an antiderivative, that means capital F prime is equal to f. Either one of those, I'm assuming, is the answer. D, integral of ft dt results in f of t plus c, or it's going to say like a general family of antiderivatives, or general antiderivative. I got nothing. The integral of sine of x is negative cosine of x plus, oh, wait a minute. I'm assuming this is intentional. If it's not, then it'd be negative cosine of x plus c, but notice there's sine of x, then there's a dt. So in this case, sine of x is actually meant to be treated like a constant. So it'll actually stay sine of x times t. Like, think about it as if the integral was like, 8 dt. 8 is a constant, so the integral would be 8t, and then I guess plus c. And so in this case, sine of x is like the 8. It's just a constant because it's in terms of x, but you're integrating with respect to t. So I'm thinking it might actually be sine of x t plus c, which is crazy. F, integral of e to the x from 0 to 2. Integral of e to the x is e to the x. We evaluate from 0 to 2. We get e to the 2 minus e to the 0. That would be e to the 2 minus 1. And the integral of e squared dx would be e squared x plus c. Once again, e squared is similar to kind of like the sine of x in the previous one, but really e squared is a constant because it doesn't have an x in it. So a constant, the antiderivative of a constant is just that constant times x. Make sure to add c. Hope this makes sense. Did the best I could without knowing the drop-down boxes. Let's do number 3. Solve the differential equation with initial condition that. So we are using separation of variables, and we're probably just going to actually, you know what? No, we don't need separation of variables. We're just taking the integral. So we're going to take the integral of -5 over t dt. The reason we don't need to use separation of variables is because there's no f or there's no y's in the mix on the right side. So we can just take the regular antiderivative of -5 over t. When we do that, we get -5 times natural log of t. Think about it as -5 times 1 over t. So -5 stays, and then 1 over t goes to ln of t. We add c, and we say this is f of t, and then we plug in the initial conditions to solve for c. And we get -8 equals -5 ln of 1/2 plus c. I guess we add the 5 ln of 1/2. That's pretty whack. That's fine. I guess they want a decimal, so maybe we'll actually calculate this real quick. -8 plus 5 ln of 1/2 or 0.5, so we get about -11.5. So that's c, so we're going to plug that back into the original function and have -11.5 like that. So we're looking for a -5 ln of t, excuse me, minus 11 over 5, or 11.5. And I think that's it. Cool. All right, so antiderivative, make sure you add plus c, and then plug in the initial condition to solve for c. Number 4, separate the variables. So we have p prime of t, which is dp over dt equals kt over p minus 1. So we need the p's on the on the left side. So we're going to multiply by p minus 1. So we get p minus 1 dp, and we're going to multiply by dt, so we're going to have kt dt. So notice they say fill the blanks with the functions you have separated into. So we have f of p dp, so p minus 1, and then we have g of t dt, which is kt. That's it. So this is that, and that is that. Okay. Number 5, solve the differential equation. Now this will use separation of variables. Notice we have t's and y's on the right side. We're going to get the y's on the left side by dividing by y, leaving the dy and multiplying over the dt. So we'll have 5t squared dt. We now integrate both sides. We get natural log of y, absolute value, and 5t cubed over 3, and make sure to add c on the right side. And then we're getting y by itself by making e the base of both sides. E and ln cancel, leaves you with y. You get e to the 5t cubed over 3 plus c, but that c in the exponent can be, you could call it e to the c, or you could just call it a big C out in front, which is what they are going to do. So we're looking mainly for the e to the 5t cubed over 3. And that looks like option B. All right, that was number 5. Number 6, which of the following equations are separable? Separable means if you get y prime or dy over dt by itself, you have basically a product of y terms and t terms on the right side. Because think about what the next step is. You're dividing by the y terms. So essentially like getting the y terms over here. You could call it 1 over y terms, but 1 over y terms is still just y terms. So it just gives you a different set of y terms. The whole idea is you can eventually separate it into y terms and t terms on opposite sides. But that's a result of, if you look at y prime and you ask yourself, can you factor it so that it's in like two separate factors for y terms and t terms? So what I mean is, like, when you look at A, we have y prime by itself, but on the right side, we have t terms and y terms separated, but they're being added together and not multiplied. So right away, there's no way we could separate these variables, because we can't just subtract the y over, because then we'd have to multiply by dt. It would mess everything up. So A is not separable, mainly because of the addition. B, we have y prime by itself, and then we have y term here, t term here. Perfect. So we have a product of y terms and t terms. So we can easily divide by e to the 5y, keep the dy, and keep the e to the 5t over 2, and multiply by the dt. Like, we are able to separate it. So B is separable. Now, notice they don't give us in part C y prime by itself, but we can try to get it by itself. Let's see what we can do. Let's add the y cubed, and then, yeah, let's just get y prime by itself. So we're going to get y cubed, y prime, y cubed plus y to the 5th ln of t. All right, so we added just the y cubed over. Now we're going to divide by y cubed. When we do so, we get 1 plus y squared ln of t. So again, we just divided the whole thing by y cubed. It got rid of it here, and made it a 1, and it took away 3 of them from here to make it a 2. Now, when we look at this, we have y prime by itself. Do we have a product of y terms and t terms? We do right here, but the plus 1 is really throwing it all off, and I don't think we can do anything with that. It's like, if this wasn't here, it would be separable, but there's really no way now to get just the y term to the left side and the t terms to the right side, while, you know, also successfully separating the dy and dt. So I'm going to say this is not separable. I'm going to go only B on this one. I hope that makes sense. If you have any questions, let me know. Number 7, you were told the following information. Following Newton's law of cooling, the original temperature of 70 raises to 150 in 10 minutes. Place in a 300-degree oven. Okay, so we're setting up the initial value. Okay. All right, so I'm pretty sure the surrounding temperature is what goes in the differential equation. So the original temperature of that raises to that when placed in a 300-degree oven. So I believe 300 degrees is the surrounding temperature. So now to find C, to find K. Okay, so interesting. Okay, yeah, definitely not the most helpful, but let's give it a shot. So I think you're meant to evaluate the differential equation. So think of it as like d theta over dt. So that's theta prime, and then equals k times 300 minus theta. I've never seen theta for the temperature stuff. That's so weird to me. Anyway, we want to divide by 300 minus theta and multiply by dt. Keep the d theta. Integrate both sides. We get the natural log of 300 minus theta. I guess use absolute values. And make sure to tack on a negative. We've talked about that before. When you have a negative on the inside, basically like the coefficient of the theta, the coefficient of the variable is negative. So had you used U substitution, it would result in a negative being on the outside. That's all I'll say there. We'll just keep it going. We integrate k, we get kt plus c. Now we're going to get theta by itself. So negate both sides. So you have a positive natural log equals a negative kt. We're going to keep it plus c. It's just a different constant now. And then make e the base of both sides. So you're left with 300 minus theta equals c e to the negative kt. And now we basically swap the places of the theta and the c e to the negative kt. And we get our general solution. So the idea then is to solve for C and for K, and that's what they're asking about here. So to solve for C, we're going to plug in something, probably the initial condition, the original temperature of 70 degrees Fahrenheit. So 70 is the original temperature of the object or cake or whatever it is, just an object. Crazy they're talking about an oven, but they don't at least give you the example of like, we're making cupcakes or whatever. They just say an object in the oven. So anyway, the original temp is 70, and if they're talking about original temp, they mean the time would be 0. So the idea is like you're plugging in 0 for T and 70 for the temp. And then you solve for C. So you get 300 minus C. E to the 0 here is just 1. So it leaves us with just C times 1 or just C. And then you get 300 minus 70 equals C. So that'd be 230 equals C. Okay. So what they're saying is to find C, theta of 0 is equal to 70. So I guess they don't even want they don't want you to solve for C. They just want to know how to find it. Yeah, okay. So in that case, to solve for K, you would just plug in 150 at 10 minutes. So you would do the temperature at 10 minutes is equal to 150. I guess that's it. So yeah, I might have worked out a little too much. Sorry. Let's keep it going. Yeah. Number 9. All right, so they're screaming at you. This is just an example. You should know how to do something like this, etc. Understood. Given the separable equation and initial condition, find the explicit solution. Okay, so we're going to rewrite y prime as dy over dt. We have minus 3t cubed y equals 0. We're going to separate the variables. We're going to add all this stuff to the other side, and I'll just do it like that. Then we're going to divide by y, so we get 1 over y dy. We're going to multiply by dt, so we'll get 3t cubed dt. We separated the variables. Integrate both sides. We've seen this one. We get natural log of absolute value of y. We add a power, divide by that power. Make sure to add c on the right side. Make e the base of both sides to get y by itself. Again, anytime you have e to something like this, just do the main portion and make sure that plus c just transfers to the front on account of simplifying. Now we use the initial condition. Y of 0 equals 6. So 6 for y, 0 for t. That's going to make everything up there 0. So that really just makes c equal to 6. And you say that y is now equal to 6e to the 3t to the 4th over 4. And that's your final solution. And that is in the format y equals f of t. So it's just, that's it. Hope that makes sense. If you have any questions, please let me know. I think that was it. All right. Good luck on your exam. Let me know if you have questions on any of this or anything else. Okie dokie. Alrighty. As they say, bye-bye.